Today we'll be doing the example 14 controls system or controls toolkit in Adams. First thing we're going to do is select new model. We'll name this model controls. Don't have to worry about this other stuff. Select OK. Next, we're going to come up here to File, select Import. On Files to read right here, we want to right click and select Browse. And you will need the lift mechanism start file. Open that. Ensure that all of these points are selected like this and click OK. Next, from the elements here, we're going to go into the controls toolkit. We're going to select the input right here. And then we are going to change this input name to theta underscore desired. Function will be zeros here. Select apply. We're going to click this function input again and create another input function. This one's going to be named theta underscore actual. We're going to click on this function builder right here. We're going to, up in this drop-down menu, select displacement. We're going to select about the z-axis. And then we are going to click assist. From the to marker, we're going to right-click it, go to marker, and select browse. And we're going to select torque IR. Hit OK. For the from marker, we're going to right-click here. We're going to do the browse as well. From these markers, we're just going to click on this most recent one and select OK. From here, we can just hit OK. And we need to check up in this define a runtime function here because these zeros tend to stick on, so we want to delete those. And it should look like this. Now we can click OK to this. Next, we're going to be going to this summing junction block. So we want to first actually apply this, then go up to summing. Up in the summing right here, you can rename this to just sum. We'll do theta underscore sum. For our input one, we're going to right click right here, go to controls input, go to guesses, and select theta desired. For our input two, we're going to do the same process, right click, guesses, and this time we will do theta actual. From here, we can select OK. Now we're going to actually go back up into here. We're going to select this gain function right here. We want to rename this one to theta gain. Then we want to right click on this input right here. Go down to controls underscore sum, guesses, and we're going to do theta sum. For this value right here, we will do E9. Now we want to make sure we hit apply here, so that way it corrects it to how it likes seeing that. And then we can select OK. Now, down on this torque right here, we're going to right click, go to torque, and modify. Where it says function right here, we're going to select the function builder. For the getting object data, we're going to go down and select measure. We're going to right click right here, go over on runtime measure, go to our guesses, and do theta gain. We're going to insert the object name. And right here, this 0 tends to stick on there as well. So you want to delete that to make sure it is the right name. Once everything looks good up in the define runtime function, we can select apply and OK. And it'll pop up right here. Now we can hit apply and OK again right here. Now we want to verify our simulation. So we'll click on the simulation tab, go to the run over here, and this is the verify button. We want to click on that, and we want to make sure that there's only 1 degree of freedom here, and there are no redundant constraints in the equation. So it looks good. We can exit out of that. At end time here, we want to change that to duration, and we want to change the duration to 2. For steps, we want to change the steps to 100. Once that is done, we can select play. And there is your simulation. You can zoom out and reset and play it again. And that is all for example 14.